So today we are going to start with the unit 4. The unit 4 we have the three topics: structures, union and pointers. In this today's session we are going to cover pointers. So these are the outlines for the pointers. First we will go for the introduction, then declaration of pointer variable, then operations on pointers, then pointer arithmetic, arrays and pointers, dynamic memory allocation. So these are the topics which we are going to cover in the today's session. So pointer is a special kind of a variable which can store the address of another variable. So if you have a variable var in your program, so address var will give you its address in the memory, that where this var is exactly in the memory. So let's see the example of scanf. So in the scanf we have the two, it takes as two arguments. The first one is the type, data type, and the second one is the where we want to store that value. So here the value entered by the user is stored in the address of var variable, right? So let's see the working example. So this is the example there. So include stdio.h int main int var is equal to 5. So in the variable var, the value numeric value 5 will be stored. So first we are just printing that what is the value in the var. So printf var %d /n var. So in place of this %d, the value of this var will be printed. So we can see here in the output, so it is written var is equal to 5 because the value of the var was 5. So now let's see that after that we have written printf address of var %p comma address of var. So what will happen here, that it will in place of this %p, what will be get printed, the value of this var will get printed. So we can see that value here. So address of var, so address of var, so this is the address where this variable whose value is 5 is stored. So this is the place. So this is actually the way, means putting the address before the variable tells you the memory location of that particular variable. Now let's try to understand again the concept of address and pointers. So here what is happening, so this is the continuous memory location. So let's say contents 1, this contents 2, this contents 3, and so on 11 and 16. So naturally in the memory we have the different locations for it, and so let's say that this is the contents 1 is at address 1, contents 2 is at address 2, and so on. So memory can be conceptualized as a linear set of data location. Variable reference the contents of the locations. Pointer have a value of the address of a given location. So what I want to tell you here is that suppose this is the contents 1. So naturally this will contain some value. Let's say I am putting that contents 1 is equal to 5, contents 2 is equal to 10. So whenever we will use the contents 1, it will give the value 5. Wherever we will use the contents 2, it will give the value 2. But suppose if I want to know that in the memory location where this content 1 is, in the memory location where this content 2 is, so what we can do is, so suppose if it is the content 1 is at address 1 and content 2 is at address 2, then how to find the value of this address 1 and address 2? So what we can do is simply we can put the symbol address of before this contents 1, so it will return you the value address 2. So now coming to the declaration of pointer variable, that how we should declare the pointer variables, because if before this you must have seen that how to declare a normal variables. So here we are going to learn that how to declare a pointer variable. So what are the variable? Variables are allocated at addresses in computer memory, and that depends on the computer or operating system. And name of variable is a reference to that memory address. A pointer variable contains a representation of an addresses of another variable. So in this one, the p is a pointer variable in the following. So now let's see on the this left side. So here I am writing int v is equal to 101. So it says that we have declared v as a integer variable, and we have given the initial value 101. And we have declared one more thing here, that is int star p is equal to address of v. So first we have to understand what this p is, right? So p is actually the int star. So which indicates that p is a pointer type variable which can store the address of integer type variable, right? So whenever you have any kind of a confusion, just you look at this carefully. So what that indicates, that star with p means it is int actually, but when I say that what is alone p, then it is actually int star. So int star means a pointer of a type integer, right? And there we can store the address of a variable which is of integer type, right? So v is a integer type. So here we have described this one. So name v and p. So v is some variable and p is some special variable, that is a pointer variable. So in the abstract representation, v contains a value that is 101 and p contains a value which is nothing but an address of this v variable, right? And what is the concrete representation? So integer takes 4 byte for int, that is the value 101, and pointers take 4 byte for memory address v, right? So this value can vary from operating system to operating system and computer to computer, right? Now let's see this declaration of pointer variable. A few more types of declarations. So C pointer. Pointers are special variable that are used to store addresses rather than values. So syntax is, we can simply write int star p. Here we have declared a pointer p of int type. Now what we can do is we can use the semicolon, that is int star p1, int star p2. So both of them are your integer pointers. You can write int star p1 comma p2. So then both the first one is the p1 is the pointer and p2 is the normal variable. So now let's see the complex example one more. Int star ap5, where ap is a type of, it's an array, right? So what we are saying here, that ap is a array, right? But the value inside the ap will be not a normal values, it will be a address of another variable. So that's why we can say that ap is an array of 5 pointers to integer. So this ap is not a normal integer array, it's a pointer integer array actually, which can store the addresses of 5 integer variables. Now coming to the address of operator, that how this what this address of operator does. The address operator can be used in front of any variable object in C. The result of operation is the location in memory of variable. So what does it mean? That whenever you put this address of operator before any variable, then what it will do, it will return the address of that particular variable. See in this example, int v, int star p. So v is a normal variable, p is a pointer type variable, and a5 is a array. So address v will return you the address of v. Address of a2 will return the address of second element, third element in the array, and address of p will return the address of the pointer p. And naturally the p will also be allocated, be acquiring some space in the memory. So that address will be returned by the address of p. Now next one is your indirection operator, that is the star. So a pointer variable contains a memory address, we know that. To refer to the content of the variable that the pointer points to, we use indirection operator. So now we will try to understand that what is the meaning of this. So now suppose if I say there is a pointer variable p which contains the address of variable v. But suppose with the help of p, I want to know that what exactly value is stored at that particular address. Then what we do is we put a star before the that particular pointer variable. So now let's see this example. So int v is equal to 101. So int star p is equal to address of v. So what we have done is we have stored the address of this v in the pointer variable p. So now suppose if I want to know that what is the value of the variable whose address is stored inside this p, then what we have to do is we have to print the value of star p. So because if we will print the value of p only, then it will give you the address of v. But if we will write star p, then it will give the value of the variable whose address is stored inside the p. So you can see here, if I write printf %d star p, then it will reprint 101, because the p is containing the address of v, and when we have put star before the p, then it will print the value which is at address v. So the value at address v is 101. Now, arithmetic and logical operations on pointers. So a pointer may be incremented or decremented. So we can do the increment as well as decrement in the pointers. An integer may be added or subtracted from a pointer. So if you have two pointers, you can subtract one pointer from another pointer. The pointer variable may be subtracted from one another. So you can subtract from one another. Pointer variable can be used in comparison, but usually only in the comparison to null. So pointer variable, we do the comparison, but in general we do the comparison only with the null, right? So that we will see in the when we will go for the structures and all. So when an integer is added to or subtracted from a pointer, the new pointer value is changed by the integer times the number of bytes in the data variable the pointer is pointing to. So we'll try to understand what is the meaning of this line. So what it want to say is that suppose we have a uh, the pointer val ptr, right, and that contains the address of double precision variable, and that address is this 234567870, right? Then the statement val ptr is equal to val ptr plus 2. So what will happen to this is that when you will do this, so 2, it will not do the 2 increment, because if it would have done the 2 increment, then the value of this would have been 72. But now what is the size of the double? The size of the double is 8, right? And we are doing the increment of 2. It means we are incrementing a pointer of double type, right? And so it means we are going ahead with the two doubles. So when we shift by one double, it will become 878, and when you will shift one more double, then it will go to 886. So that's why the increment is of 16, right? So now I explain you this again. So what we want to say here is that whenever you do any increment or decrement in a pointer, then the increment is not what exactly that value with which you are adding. The increment will be that what kind of a pointer it is. If it is an character pointer, its character takes 1 byte, so it will be incremented by 1. So if it is a integer pointer, if that integer, if that operating system gives 2 bytes to integer, then the increment of 1 means increment of 2 byte. If you are using the double takes the 8 bytes. So if you are increment with doing the 2, then it means you are adding the 16 to it. So this is what happens when you do any arithmetic operations with the pointers. Now using the C language special keyword. So there is a special keyword size of. The purpose of the using this special keyword size of is that whenever you put this size of operator, then it tells you that what is the size of that particular, whether it is a variable, whether it is a constant, whether it is a uh, data type. So it will tell you the size of that particular thing. So here you can see that if I write size of array divided by size of double, so what it will do, it will return the 10. Why it is returning? Because size of array is how much? If array is of double size, then how many will be? So double is taking 8. 8 into 10 is equal to 80. So the size of array is 80, and the size of double is 8. So 80 divided by 8 is equal to 10. Now there is a relationship between pointers and the array. So now how that relationship is: when an array is declared, the compiler allocates sufficient amount of storage uh, to contain all the element of the array in the continuous memory location. We know that, right? The base address is the location of the first element, index 0 of the array, right? So the compiler also defines the array name as constant pointer to the first element. So this point is very important. So now what we want to say here is that if you talk about only the name of the array, then the name of the array is nothing but it is the address of the first element, that is at index 0 of that particular array. So we will try to understand this with the help of this example. So now consider the declaration. I have written int x5 is equal to 1 2 3 4 5. So suppose that each integer requires 4 bytes, right? So compiler allocates a continuous storage of 5 into 4, that is 20 bytes. So suppose the starting address of the storage is 25000, then the address of the first one will be 2500, address of the this x1, that is the location 2, is 2504, 2 it is 2508, 4 it is 2512. So now what I want to tell you here is that what is the meaning of x. So if I will use the word x only, then it will indicate that it is the first element, address of the first element. Now let's see how. So now let's see this example. So program to compute the average of all the integers in an array using pointers. So int x is equal to 100, k comma n, right? Scanf %d address of n. So now what we are doing is, in the n we are storing the number of elements. So for k is equal to 0, k is less than n, k plus plus, we are storing all the value in the array x, right? So printf average is %f average x comma n. So we are calling the function average x comma n. The first parameter is the array and the second parameter is the number of elements. So now we have sent these two parameters to the average function. The first one is the integer array, second one is the integer size. So now here we have declared a pointer p. I is an integer, sum is an integer with value 0. So p is equal to array. So as I told you, the name of the array is nothing but it is an address of the first element. So what we have done in this pointer, we have given the address of the first element of the array. That means what this array means? This array means the address of array 0, right? So now what we have to do is, how we can access with the help of pointer, how can we access all the elements in the array? So for I is equal to 0, I is less than size, I plus plus, right? So we are going from 0 to less than size, whatever the number of elements was there. So what it will do, sum is equal to sum plus star p plus I. So p is what? P is the actually the first element, right? And I is the, initially I is 0. So it means p plus 0 is p only, and star p will give you the value of the first element in the array, right? In the second iteration, I will be equal to 1. So what will happen? P plus 1 is equal to, if it is an integer, so it will be an increment of 4. So naturally the next address in the array will be how much? That is the current one plus 4, right? And the value stored at that will be returned. So exactly what will be happening is that it will be returning the value which is at the second location of the array, that is the index number 1, that is array 1. So that way all the values stored in the array will be added up in the sum, and at the end what is happening, it will return all the sum divided by size. So it will return you the average of it. So it will come back here, that value will come to this average x comma n, and it will be printed. So this is how we can access the elements of an array using a pointer. Now coming to the next one, that is the dynamic memory allocation. So now why this dynamic memory allocation is needed? First we will try to understand that. So there is a problem with the array. So what is that problem? The problem with the array is, suppose I don't know that how many elements will be there. So what we usually do is, we just take the enough size array and then we insert the element in that using scanf function, or we do the initialization at the compile time. So what happens is, suppose I don't know that how many elements I'm going to store in the array, and there are total I'm going to store only 10 elements, but I don't know how much that, and I will allocate the memory for 1000 elements. So what happens there? There we are wasting the space, 990 spaces will be wasted in that array. So then what we can do to save this space? We can do the dynamic memory allocation. Now, what is the meaning of dynamic memory allocation? Dynamic memory allocations means when you run the program, actually, then you know that how many elements you are going to store here in the array. So we do the memory allocation at that time in spite of doing at the compile time, right? So I hope that you know the difference between compile time and run time. Okay, I will explain you again. Compile time means when you compile your program, at that time, if the memory allocation is done, that is called the compile time. So in the array, we do the memory allocation at the compile time. So how that is done? You just write int a5. So you do, what you do is, when you compile your program, there itself it allocates the 5 into integer size memory for that. And runtime means you compile your program, but when you are entering the value at that time, you are giving the input to it, and then it is allocating the memory. So as I told you that the solution for this problem is dynamic memory allocation. So so this is the solution for this. So what are the functions which can be used to allocate the memory dynamically? The first one is the malloc, then calloc, and then realloc. So now let's see these three functions. Memory allocation function. The first function with the help of which we can allocate the memory is malloc. It allocates the required number of bytes and returns a pointer to the first byte of the allocated space. So the syntax for this one is you have to give the data type and then star p. P is the variable, it's a pointer variable. So here malloc and then total number of bytes that we for which we want to allocate the memory. So this malloc function allocates the memory for wide data type, right? So but anyway we always have the type of data type. So what we need to do is we have to typecast this with the data type, the type of data type, right? So here we typecast it, and then this is the p is the pointer which points to this memory location, right? The second one is the calloc. The difference only between the malloc and calloc is the in the calloc we have the two argument. The first argument is that how many numbers, right? And second is the what is the size of a byte. So here what we can do is here we can say that we want suppose we want to allocate the memory for 10 integers. So we will simply write here number means 10 and how many bytes the integer takes. So as we are considering 4 byte for an integer, so it is 4. So 4 and the byte for each element, and how many elements, that is the number. So that is the number of elements. Rest remains same. Only the difference here is that it initializes them to 0 here, right? Second one is your third one is your realloc. So it modifies the size of previously allocated space. So what happens, suppose I have allocated some memory, right? But in the program itself later on I think that I may need the more memory space. So what we can do is we can reallocate the memory. So what are the parameters that we have to give? The first is the old pointer. We have to give the old pointer address, and the second the new size, that how much big you want this new one. So suppose previously we have allocated the 10 bytes for a purpose, but later on we think that 10 is not sufficient, we need the 50. So what we will do simply is, suppose the previous memory allocation was at we were using the pointer n for that. So what we will do is we will write here n, and the new size is 50, we will write 50 here. So what will happen, that pointer p, the new 50 new spaces will be created, and all the memory previous data which was in the old pointer will be shifted to this. And the last one is, this is the free function. What is the work of the free function? Because the memory which is created by us should be removed by us only. So it frees the previously allocated space. That is the job of the free function. Now, allocating a block of memory. A block of memory can be allocated using the function malloc, reserves a block of memory of specified size, and return a pointer of type void. The return pointer can be typecast to any pointer type that I have already explained, and the general format is type star p, and p is equal to type star malloc byte size. This I have already discussed in the previous slide. Now let's see one example. So this malloc function, a memory space equivalent to 10 times the size of int byte is reserved. The address of the first byte of the allocated memory is assigned to the pointer p by the int type. So with the help of this example, what I want to explain you here is that suppose I wanted to store the 100 integers. So in the malloc function we give only one value. So size of integer will return the value 4. 4 into 100 means 400. So 400 byte of space is created here. So now the question comes that how I will access this particular uh, space, right, where we have allocated the 400 bytes. So as in the case of array, what we do, I have told you that the name of array gives you the address of the first element, right? So here also this p contains the address of the first element of this newly allocated memory. So this is how it is used. And so later on what you can do is, if you write p plus 1, that is this address. If you write p plus 2, that is this address. If you write p plus 3, then that is this address, and so on. So that is the use of the arithmetic operation on the pointers. Because if I say increment 1, then it do not increment the value 1, it increment the size of the data type which is stored in that particular pointer. So here you have a pointer char malloc 20. So it allocates 20 byte of space for the pointer cptr of type char, and in this it allocates the 10 into size of structure. So there is a structure name stud which might have been used for the student, right? So what it will do, whatever the size of structure is there, you multiply that with 10, and so that much total space is allocated for this. So what the suggestion over here is that do not write directly the size. So it is always advised that you use size of operator. So this is what is written here. Always use size of operator to find number of bytes of a data type, as it can vary from machine to machine. I have told you many times that the size of data type can vary from machine to machine and operating system to operating system. So it is always advisable that whenever you are allocating the memory, you use the size of operator. Now malloc always allocate a block of continuous byte. The allocation can fail if sufficient continuous memory space is not available. If it fails, the malloc returns null. So what is the use of this? That if the memory is not allocated due to any reason, then it returns the null. So what we can do is, while allocating the memory, we can compare the value of this p with null. So if the value of this p is equal to null, that simply indicates that memory could not be allocated, and so we have to take a necessary action on that. So here you can see, if p is equal to this, means p is allocating a memory, but if it could not be allocated, if its value is equal to null, then we simply give the warning message, memory cannot be allocated. Now in this slide, I will explain you that how a malloc array can be used. So once the memory is allocated, it can be used with pointers or with array notation. Now let's see this example. In these examples, you have int star p. It means p is a pointer, n is a normal integer, and I is a normal integer, and we have stored the number of elements in the n using this scanf function. Then we have used the malloc function to create the space for n number of element that is of integer type, right? So now how we can store the value in this p? We are using the array notation to store the value. Although this it is created using the malloc function, but we are using this p as we do in the array, right? So just we are writing simply here scanf %d and then address of pi. I is 0, so p0. So that first value will be stored at p0, then next at p1, p2, p3, and so on. So here this is the one way that we can access the array location, that is p1, p2, p3, like that. Or what we can do is, the n integer allocated can be accessed as star of p. So star of p will return the value which is stored at p0. Star of p1 will return the value which is stored at the p1. The star of p2 will return a value which is stored at the p2 array, right? So this is how we can use either this array type or the pointer type. So now let's see that how we can do that with this help of these examples. Int main, int I n, float height, sum average, printf input number of students. So in the n we are storing the total number of students. So height is equal to float malloc n into size of float. So whatever the value of n we have stored, that we are going to multiply with the size of a single float variable, so that this much memory is allocated, and it is pointed by the pointer height, because height is a floating point type pointer. So printf input the height for %d student. So now we will input the heights for all the students, let's say. So for I is equal to 0 to I is less than n, so all this value will be stored in the array height. So height is a pointer which can be used as a array also, because we have created the enough memory for this. So now for I is equal to 0, I is less than n, I plus plus, so sum is equal to sum plus height of I. So it will sum up in the variable sum. So how the average can be found? Average is equal to sum upon float of n, right? So this type casting was needed here, so that's why it is done. So it will the value will be stored in the average, and at the end we can print this value, printf average height is equal to %f, whatever the value of average will come out. And then after that, what we are going to do is at the end we are going to free this height, because this memory is created by us. So it is the duty of the programmer that the programmer must free that particular memory. Otherwise, it will be consuming this memory unnecessary. And at the end, return 0 because we have used the int main. So it will return 0. Releasing the allocated free space free. As I discussed you previous also, I am discussing again. So an allocated block can be returned to the system for further use by using the function free. So we can use the function free to release that allocated memory. General syntax is free PTR. PTR is the pointer to that particular pointer, right? Where PTR is the pointer to the memory block which has been previously created using malloc. Note that no size needs to mention for the allocated block. The system remembers it for each pointer return. So when we create the memory, the system remembers that how much byte of memory was created at the time. So we need not to give any size in the free function, right? So that's all for this dynamic memory allocation and pointers. So following are the references used. So this is my mail ID. You can contact me at this sansar.chauhan@galgotauniversity.edu.in. Thank you very much.